Be working with Odeon, computer acoustic modeling software. There are many other computer modeling softwares such as CAT, Acoustic, and Easy. We will begin by importing the geometry of the room you require to use into Odeon, and it will be in the DXF format. Um, Once it is imported, you will see that it's placed on an X, Y, and Z axis. Z being the height, X and Y the rest. What you want to do is get in sources and receivers. So when you click on point source editor, you can input one source, and it will have X, Y, and Z coordinates. So changing that, you can relocate the point source wherever you require on in the geometry of the room. So that's what we'll do. We will let's put a point source at 4 meters away from the x-axis and at a height of 1.6 from the floor of the podium. Once we do that, let's now put a receiver in the geometry as well. As you can see, the audience floor kind of moves away from the x-axis. So once the receiver has been placed there, from the x-axis it will be 8 meters away, but at a height it will not remain the same. We have to specify if you want to put an actual height of 1.6 meters, the height would increase with respect to z-axis, so it would be 1.92 meters. Next, we want to clone the receivers and get how many receivers in the entire geometry. So by clicking tabulate receiver, we can now we can change the number of receivers based on the x and y positions. So for now, let's keep 7 receivers on the x-axis, and I'm also giving them an azimuth angle of 11 degrees to give a little complication. Once we've done that, you can now see that the receivers and sources have been placed inside of the geometry. The next step would be to assign materials to each and every surface of the geometry. In this case, it's a very simple geometry, because there's just the podium floor, the audience floor, the 2 walls, 2 side walls of the audience, the end wall, and the ceiling of the podium and the audience. Assigning the materials should be simple. We basically assign 10%. For now, we are assigning 10% absorption surface to almost all of the surfaces, just as an example. And let's assign a different material to the main audience floor that consists of chairs with the light upholstery, and also the side walls we will assign plywood sheets of the audience floor, that is. By clicking quick estimation, immediately we can get calculations and of reverberation times. So by clicking quick estimate reverberation, we can now see a quick estimate of all the reverberation times based on Sabine calculations or Eyring or Arrow Picatus. These are at all the frequencies, and you can find the reverberation times for that. Other graphs are also provided in the quick estimate, where it will tell you what type of material and how much is installed in the room, or it's also going to tell you where you could put more absorption in the room, or what types of absorption coefficients have been defined in the room. There are three. After we complete that step, we will go to the option called job list, where we will now start doing the real calculations. There are three types of responses we can work with. One is a single point response, multi-point response, and grid response. We'll start with the single point response. The single point response basically calculates the reverb of the room and gives you values such as EDT, T15, T20, T30, etc. It also gives you energy parameters, decay curves, reflection density, reflectogram, and it also shows you the 3D reflection paths of the point source ray, and you can follow ray trace all the reflection paths as well. In the multi-point response is where this paper is about. We can group together all the different receivers that we have assigned on the audience floor, and we can compare the reverberation times between each receiver. As you can see, it will then give us energy parameter curves, which based on EDT or T20 or T30 or even SPL, as you can see. Next, in the grid response, once we tabulate the grid response, we can choose the auto option, and the computer will choose the floors and the ceilings to create a grid response. For this example, we have chosen only the floors, and we've received, as you can see, a grid response where every square is a point, a receiver placed in every square. The grid can also be even more smaller, with more number of squares. That means more number of receivers will give you the reverberation times at each point of the room, and that will be more detailed than the one you see right now. What we will receive as calculations is the mapping of the grid and a distribution graph, which will show you how all the reverberation times are spread out in the entire room, and we can view them in the EDT values at 1000 Hertz, or the T30 values, or the SPL values. This is what my paper is about. Thank you.